I think a lot of you already know Aditya, but he's a PhD candidate in the Computer Science and Engineering department at the University of Washington. And he spent a lot of time at Microsoft Research Bangalore as one of their associate researchers. Is that what they call it there? Assistant researcher? Assistant researcher. So that's where kind of a pre-PhD program where you spend a couple of years doing research at the lab. And so Aditya's work in particular focuses on computing in low resource environments, such as India. And his work has been recognized with Facebook Fellowship and with Best Paper Awards at Chi and Assets. And of course, it's also had a lot of impact through real deployments that have reached thousands and thousands of users in India and also Africa, I believe. So we're really excited to have Aditya here speaking today. For people who are joining us online on Teams, we have the volume in the room turned off right now so it doesn't create feedback. So if you have questions during the lecture itself on Teams, just type them in the chat window and I'll raise my hand and ask them for you. And then at the end, we'll also have Q&A and we'll turn the microphone for Teams back on for the Q&A at the end.
Cool. All right. Good morning, everyone. Thank you so much for coming to my talk. Today, I'm very excited to share my work on how social computing can be used for social good in low-resource environments. Social computing platforms like these have revolutionized how most of us in this room produce, consume, and share information. They play a pivotal role in connecting us and providing us with up-to-date information. Despite their imperfections, these platforms are an integral part of our daily lives and have deeply impacted our society. But these platforms currently exclude billions of people worldwide who are low literate, who speak low source languages, who live in severe poverty, or those who do not have smartphones and connectivity. To include these people in the social computing revolution, most technology companies have primarily focused on bringing connectivity to low resource environments. For example, companies are using drones, balloons, and unused TV spectrum to improve connectivity. And although these are great first steps, just improving connectivity is not enough because there are several other technical, social, and cultural barriers. As an HCI researcher who is motivated to solve these barriers, I can speak for hours about how each of these barriers makes it very difficult to connect people. But in the interest of time, I'll briefly highlight a few of them. Focusing on India, where I've done a lot of my research, a high majority of people there use feature phones. Now, unlike smartphones, it's very difficult to create a standardized feature phone application that works on all feature phones because there are hundreds of proprietary operating systems, most without any API documentation or developer support. Now, even if people have smartphones, literacy and language barriers makes it difficult for many to use them. And just as an example, 26% of people in India are illiterate, and they find it challenging to use text-based interfaces. Using voice assistant softwares like Cortana, Google Home, Alexa, and Siri are also very challenging because most Indian languages do not have recognition models and training data. In fact, there are some languages which have millions of speakers, but these languages do not even have fonts. Now, as technologists, even if we solve technical barriers to provide people smartphones, connectivity, and power to charge their devices, social cultural norms impact the systems that we build. For example, a high majority of women in India are prevented from using mobile phones and internet. And these are just 3 barriers that I've spoken about. A combination of these barriers makes it very difficult to connect people in low resource environments. And to make matters worse, these environments have marginalities within marginalities, which means that some sections of society are more marginalized than others. For example, 80% of persons with disabilities live in low resource environments in developing regions. 90% of these children do not attend school, which means that they have no knowledge and skills for employment, well-being, and overcoming poverty. And a high majority of women undergo physical abuse and sexual abuse. And in addition to these social, cultural, physical, psychological marginalization, people with disabilities are also technologically marginalized because they encounter huge accessibility, usability barriers in using smartphones and internet platforms. My research goal is to build social computing technologies that are accessible and inclusive to all people. I am motivated to bring the benefits of social computing to people with disabilities and also to billions of those who are excluded because of literacy, language, socioeconomic, and connectivity barriers. In particular, I am driven to connect them, provide them information, and bring social and digital equity to them. Towards these goals, I have used a broad spectrum of interdisciplinary methods from computer science, HCI, design, accessibility, social sciences, and behavioral psychology. And using these methods, I have built 9 social computing systems for people in low-resource environments. I have systematized how these new users produce, consume, and share information by using quantitative and qualitative methods. And I have deployed these social computing systems in real-world settings by partnering with governmental agencies, social enterprises, and grassroots organizations. And together, these systems have reached an estimated 220,000 people in low-resource environments. So let's find out what are these social computing systems. To connect people in low-resource environments, I have designed and built voice-based social computing services by using interactive voice response technology. IVR technology is what you use when you call your bank or insurance service provider and press 1 to access your account information or press 2 to speak to a customer service representative. The voice-based services that I built allow users to call a number and record voice messages in their local language and listen to messages that are recorded by others. So let's see an example of how these services work.
संगीत स्वर में आपका स्वागत है। संदेशों को रिकॉर्ड करने के लिए 1 दबाएं। संदेशों को सुनने के लिए 2 दबाएं।
So as you saw in this example, users call a toll-free line, and once the call is connected, they press 1 on their phone keys to record a voice message and press 2 to listen to messages that are recorded by others. And all these conversations are happening in their local language. The design of these services overcome literacy barriers by using speaking and listening skills, language barriers by using local language and dialect of users, socioeconomic barriers by using toll-free lines so that even poor people can call these services, and connectivity barriers by using ordinary phone calls from any types of phones. The inclusive, accessible, and usable design of these services has motivated not only me, but several other development researchers and practitioners who have applied these services in diverse domains such as health, agriculture, civic engagement, employment, education, and many others. And together, these services have received millions of calls and voice messages in local languages from marginalized people. In fact, these services are perhaps the only way by which a lot of people are connected to each other and produce and consume information. Yes.
For
Yes.
a service like that, all you need, it seems, to start, it's some service associated to a toll-free number,
Correct.
which can record messages and playback.
Correct.
That's it.
Absolutely.
Not much more than that.
Nope.
As a starting point.
Absolutely. 100%.
Wow.
Now, yes.
I'm sorry, I didn't understand though. When they listen to recorded messages, which ones do they get?
Yeah, so that, and we'll talk a little bit more about it, but essentially all the messages with which other people are recording. And there are really interesting questions on for which ones they are going to listen, because when they're listening to these messages, it takes up a lot more time than skimming these messages.
Right.
Absolutely, and I'll talk a little bit more about it. In fact, this question is a great segue. So all these services are great, but there are 3 fundamental challenges which negatively impact these services. The first challenge is that users record audio content in local languages and dialects, so it's very difficult to search, index, and moderate these messages. The second challenge is that users call these services via toll-free lines, where the cost of voice calls is paid by these services, and it makes it difficult to financially sustain them as the usage grows. And third, these services are technically challenging to build and maintain for global development organizations and grassroots agencies, which makes it really difficult to replicate them in new contexts, and because of which the impact is dramatically reduced. Bank of America pays someone millions of dollars to build their IVR services. And these millions of dollars are often beyond the reach of a lot of global development organizations and grassroots agencies. So these 3 challenges result in poor scalability, sustainability, and replicability. And I found it disheartening to say that because of these 3 challenges, most of the services that I showed in the previous slide are currently not running. And this is very frustrating. So most of my talk today is going to focus on my efforts on creating scalable, sustainable, and replicable voice-based social computing services. And although the talk is going to focus on work in Global South, my work has interesting implications for people in low resource environments in the US and other developed regions as well. I have worked with people with vision impairment in South Seattle, refugees communities in Seattle, and those projects are the interesting extension of the work which I have done in the Global South. Disability is an important part of the work, and I'll talk a little bit more about it during the later part of the talk. So coming back to these services, let's first focus on the content moderation challenge. Now, when you browse a Reddit channel like this, it hardly takes us a few moments to recognize that there are 4 posts focusing on Canada, Amazon, NRA, and a study in the UK. Now imagine calling a voice-based Reddit-like service that has thousands of audio messages in local languages. It's clear that you'll have to listen to all these messages sequentially, and if the first few messages are of poor quality, you may never call the service again. It's also very difficult to skim, categorize, and search these messages. And to improve the experience of millions of users who use these services, it's important to categorize these messages, review their quality, and decide their playback order. Now, many services often hire a dedicated team of 10 to 15 moderators who listen to each voice message, extract metadata information like content type and gender, and review the quality to ensure that only high-quality messages are available for public consumption. And this approach works fantastically well when a service receives hundreds or thousands of audio messages per day. But if these services grow by orders of magnitude to match the scale of Facebook, WhatsApp, or Twitter, it would be very difficult to comparably grow the moderator team. Now, various internet websites such as Reddit and Stack Overflow face the exact same challenge, and they use community moderation to manage user-generated content. And in this work, I explored exactly that. Can community moderation be used to manage content on these voice-based services? In other words, can marginalized users of these services who are using a social computing system for the first time in their life be able to search, moderate, and categorize these messages? To examine these questions, I designed and built Sangeet Swara, a voice-based social media service that enabled users to record, to listen to, and more importantly, to vote on these songs, jokes, poems, and other cultural content. Swara used these community votes to categorize and moderate these messages. To use the service, users called a toll-free number, and once their call was connected, they could press 1 to know how many people have liked or disliked their messages, press 2 to record a new message, and press 3 to listen to and vote on messages. So let's see what happens when user's phone call is connected and they press 3. You can see the translations at the bottom of the screen.
बलराम भैया इलाहाबादी प्रत्युत्तर चैया पवन ज्ञान देवैया पवन पवन ही पवन का संचार है भैया पवन मालिक निरंकार है।
अगर आपको यह संदेश पसंद आया तो 1 दबाकर अपना वोट दें। अगर आपको यह संदेश पसंद नहीं आया तो 2 दबाकर अपना वोट दें। इस संदेश को वापस सुनने के लिए 3 दबाएं। इस संदेश को औरों को सुनाने के लिए 4 दबाएं।
So get an idea that while users are listening to these messages, they are pressing keys on their phone, keypad to cast votes, and these votes are used to moderate these messages, categorize these messages, and review their quality. Now, it's very difficult to use existing collaborative filtering techniques to moderate audio content because of differences in the properties of voice and text, features of IVR interface and text interface, and challenges in automatically extracting features from audio files that are recorded in local languages. And that's why I designed new community moderation algorithm to order and rank these messages based on users' votes. To order messages, Swara mixed high-quality messages and new messages to maintain a balance between novelty and popularity so that both listeners and contributors have a good experience. And to rank these messages, Swara gave high score for messages with high ratio of upvotes to downvotes, meaning that these messages were of high quality, and expressed high confidence in the judgment when more people voted on these messages. And after incorporating this community moderation algorithm into the design of Swara, I seeded it with 15 songs and poems and shared information about it with 73 people in rural India. And in just 11 weeks, the service received 25,000 calls from nearly 1,500 users who recorded more than 5,400 audio messages, casted nearly 140,000 votes, and listened to all these files more than 200,000 times. The average call duration was 5 minutes, and as you can see in the map, the usage spread all across North and Central India. The user analysis indicated that more than 50% of the users were living in rural areas. Almost all of them were men living in low-income environments. With respect to their occupation, more than 50% were students, and the rest were teachers, farmers, and musicians. And more than 1/4 of the users self-reported themselves as blind, and this number in reality was actually much higher. And I'll talk about these numbers in a bit, but 80% of these users who were using this service were using a social media system for the first time in their life. Now, for community moderation to work, the users need to deeply value the community and should have a desire to improve it. So the first thing I measured is whether users valued their interaction with the community members. The content analysis indicated that more than 80% of the messages were generic content, songs, poems, jokes that followed the standards of the community. Generic content included compliments and greetings to other users, and discussion on topics of national and regional interests. Songs included a much wider variety of content such as recognizable hits, folk music, solos, duets, a cappella, and even pieces with instruments. If I don't get a job, my backup plan is to mix all these songs in the CDs and then sell them. Now, though I didn't design the system exclusively to be used by blind people, Swara found broad and impassioned usage by them. They recorded strong positive sentiments about the service and shared interesting anecdotes about how the service was impacting their lives. A low-income blind user reported, "I couldn't get educated. I want to thank you because you enabled all blind people to get in touch and share. No matter how much I praise, it won't be enough." I was really curious to see if low-income blind people would derive the same benefits if they used mainstream social media platforms like Facebook, WhatsApp, and Twitter. And I found that even if low-income blind people have access to devices, connectivity, as well as literacy skills, they still face several secondary barriers that negatively impact their participation on these services. And again, I can speak for the remainder of the talk, why is that so? But just to give you a few highlights, low-income blind people had no training on how to use accessibility tools and how to navigate these platforms which have complex user interfaces. Their experience on Facebook was as if it's Amazon, a platform to buy and sell products, because they were not expecting advertisements. And when advertisements started showing up, they were like, okay, this is where I make a post to sell something. So their mental models were also very different. And those who were using these services faced huge accessibility, inclusivity, and usability barriers. Even the screen reader tool, the screen reader software and accessibility tool did not work well when messages contained abbreviations and code mixing, when more than two languages are mixed with each other when they were typing messages for others.
I'm curious, did you have any problems with objectionable content that someone would have to remove, or is that just not an issue?
Definitely, and it's a huge issue, and I'll come back to it at the end of the slide. So, in contrast, the design of this service put blind people on equal footing with sighted people and made them feel more included and confident. In addition to blind people, the service saw great adoption by low-income people who perceived it as a platform for rural users and musicians. A musician in peri-urban area reported, who was also blind, Swara is trying to get talent from people in villages and towns. It is getting recognition to those who never got an opportunity to show their talent. And the users also self-reported improving their confidence, grammar, vocabulary, communication skills through its use. And all these benefits were self-reported. We didn't even actually ask them, were there any improvements on the instrumental benefits. A low-income farmer reported, some people record questions, which increases our knowledge. We learn new vocabulary and accent. I feel great when people give me feedback. I consciously think of ways to improve my messages. And collectively, these findings indicate that users indeed valued their interaction with the community members. Yes?
When you're talking about community members, are you saying the system itself is the community, or because you're going across India with a lot of people?
Thanks for clarification. So by community members, I mean people who were using that system, which were generally of the same socioeconomic strata, were generally facing the same kind of challenges, were of course distributed geographically, but had a lot of similarities with them. But community of the users who were using the service. Yes?
And sorry, within the system, was there a structure like friends in Facebook, or is
Nope.
it just sort of one big open?
So not in this system. So because we wanted to design something really simple, we weren't sure like how people would react to this voting mechanisms. Because I mean, for some of these people or in some of these like communities, like when people are using an interactive voice response service for the first time, they think that they are talking to someone. So the mental models are really different. So we weren't even sure like if this would work out, that they would understand that they should vote and how these votes are impacting moderation and categorization of these messages. So in this system, there were no like friends or subgroups, but in other systems we have built those and they work fine as well. Yes.
How long did you leave the system up, and what did the traffic look like over time?
Yeah, and I'll show you the traffic in a bit, but the traffic was growing. It was just, so one thing to note here is that we told 73 people about the system, and it grew to 1,500 just by word of mouth. We didn't do any advertisements. It was essentially just like keep going up. And after some months, like we actually had to pull the plug because we were out of funding. Yeah.
And the only feedback people gave was the single binary, either up or down.
Correct.
And there was no questions like up or down for this topic or that topic.
Yes. So, and that's, you always ask me the questions, which is the next slide. Thanks for asking it because you're right. So, yeah. So in this slide, I want to talk about how we conducted a series of evaluations to examine the extent to which users categorized and moderated these messages. To categorize content, users identified the gender of the recorder and the type of content, all by pressing keys on their phone keypad, with a response rate of 93% and accuracy of 98%. So in this case, they were asked questions like, now you're going to listen to a message. Press 1 if it is recorded by a male. Press 2 if it is recorded by a female. Press 3 if you're confused. In case of content type categorization, they were asked, press 1 if it is a song, joke, and similarly. So we had like different questions which were changed, but the modality by which they were giving feedback was always up 1 or 2, or press like upvote or downvote and things like that. Now, as you may recall, the votes from users determined the quality of the messages. So I examined whether low-ranked messages and high-ranked messages differed from each other. And I found that most messages that were poorly rated by users contained inappropriate and miscellaneous content, and most messages that were highly rated by users contained high quality and meaningful content. I also found that messages from female users received more favorable response from users. Again, I'll talk a little bit more about the abusive content and inappropriate content farther down the line. So I then examined how well did community rank and moderated these messages compared to expert moderators. And I found that users made meaningful distinction between top quality messages and bottom quality messages and performed judgments that were in 90% agreement with the expert moderators. And finally, I qualitatively examined whether users understood how their votes impacted categorization and moderation of these messages. And I found that most users understood how moderation worked, which was a big surprise for us, and were satisfied with its quality. So my work on Swara made 2 significant contributions. I built the first community-moderated, voice-based social media service that connected people, provided them information, and gave them digital equity. And I demonstrated that low-income, low-literate people, rural residents, and blind people can moderate themselves without any outside support. Swara has inspired several global development researchers and practitioners to use community moderation to manage content on these voice-based services. Just as an example, researchers in Pakistan now use community moderation to manage content on a service that has received 250,000 calls, messages, and votes. Now, after this work, I tried several approaches to address the financial sustainability challenge. To remind you, users call these services via toll-free lines, where the cost of voice calls is paid by these services, and this makes it difficult to financially sustain them as the usage grows. So I first examined, would users pay for calling a service they deeply value and passionately use? To investigate this, I converted the toll-free lines to regular lines at the peak of Swara's usage. But soon after the conversion, the usage dropped to 0, indicating that users cannot pay for voice calls even to use the services they deeply value. I then examined, can incentives prompt people from a slightly higher income group to pay for voice call costs? I hope that if this new service grows to a larger scale, then profits from paying users could be used to cross-subsidize participation of low-income users. To investigate this, I relaunched the exact same service in an urban environment and gave users financial incentives in the form of chances to win a smartphone each week, with the hope that these incentives are going to seed long-term participation. But soon after the last smartphone was awarded, the usage again dropped to zero, indicating that this approach also cannot be used to address financial sustainability challenge. I then asked, is there a way to reduce cost at least for those users of these services who own a smartphone and use the internet? I found that building a smartphone application that works exactly like an IVR application and uses voice channel instead of which uses data channel instead of voice channel to upload and download voice messages can reduce the cost of participation by a factor of 25. And you can imagine that I was pretty happy when Mark Zuckerberg mentioned this application in his internet.org speech. But this approach alone cannot address the financial sustainability challenge because only a few users of these services own a smartphone and use the internet. I then investigated, can users complete some useful work on their mobile phones to get free airtime to use these services? And all of us know about crowdsourcing marketplaces that have enabled millions of low-income people to earn money by performing micro-tasks such as image tagging, keyword tagging, transcription, and translation. But these platforms are inappropriate for typical users of these services who often do not have connectivity, devices, and literacy. And even if these people have access to devices, connectivity, and literacy skills, prior researchers, including some of those who are in the room, have shown that low-income students or low-income people and blind people face huge usability, accessibility, and inclusivity barriers in using these crowdsourcing marketplaces. So although I started exploring digital work ecosystem in the context of financially sustaining voice forums, I quickly realized that there is a much bigger opportunity to enable illiterate people and basic mobile phone users to earn money. I hoped that if illiterate people, basic mobile phone users can do something useful by using their existing devices and skill sets, then profits from that work could be used to provide them earnings, as well as a small portion of those profits could be used to provide them free airtime to use these services.
So I'm curious, the most common thing around here would be to seek advertising.
Yeah, great question.
So is that something you skipped, or because this seems more ambitious and nobler? But
yeah, definitely. So advertising was something which was definitely on the mind, but most of these services are driven bottom up, are provided by generally organizations which don't have high operating budget. And advertising is really lucrative when it reaches a larger scale for advertisers to come and showcase their product. So generally, Facebook is fantastic for advertising because there are 2 billion people who are using it. In order to reach this scale, it requires a huge initial investment because you are paying for cost of voice calls to reach the scale at which the advertising is going to be useful. And a lot of these organizations do not have that initial investment. Having said that, there is an existential proof that there is a company in India which has $5.4 billion of revenue. So they created a service which is exactly similar to the one I showed earlier, and people use it for entertainment, and they use it to advertise their products to them. So there is an existential proof, but that model doesn't work for most of the services that are deployed all across the world. Yes?
I assume it's also potentially a problem if these services are specifically targeted at very low income users, that they probably aren't a great market for advertising products.
So for that company, the reason, so they make everything like shampoo, soaps, and in developing regions, generally you get a shampoo for a sachet size shampoo, which cost one Indian rupee, which is nothing, and a lot of people can afford it because they can't buy a big bottle, which would cost them $3, but they can definitely spend 1 cent in buying a shampoo, which is just this little. So this model of providing services in very small, cheap packaging is really popular in a lot of low-resource environments, and that's why that company is using that service to market those sachets and really small soaps, which could be used just maybe 1 or 2 times, and that's it. But in general, yes, with advertising, it's a good and interesting problem because most of the things for which people want to advertise is not available or is not usable for these communities because of the price. So that too. So towards this ambitious goal, I needed to create a new crowdsourcing marketplace that works on basic mobile phones and use voice as the modality to do tasks. But with these design constraints, the key question is, what is a compelling problem that can be divided into voice-based microtasks and generate revenues? And many of you may have used speech transcription services for your work, but speech transcription is the process of converting an audio content of a file into the equivalent text. And speech transcriptions are really popular, huge industry, and therefore there are several solutions such as manual transcription, using online services, as well as submitting the files directly to speech recognition engines. But these current solutions yield transcription either with poor accuracy or high cost for audio files containing local languages and accents. And just to give you an estimate, the average market rate for Hindi and Indian English transcription is $5 per minute. So collectively, in this work, my goal was to design a voice-based, phone-based crowdsourcing marketplace that facilitate transcription of lower source languages and accents so as to generate enough profits to provide earnings as well as free airtime to users. To this end, I designed and built Reespeak, a voice-based crowd-powered speech transcription platform that combines the benefits of both human intelligence and speech recognition systems. Instead of transcribing audio files by typing, an arduous, tedious process in which you have to listen to a segment, remember it, type it. By the time you are typing it, you forgot what you heard, so you go back and forth. And if you have to punish someone, just ask them to transcribe an audio file for you for 1 hour. But instead of transcribing audio files by typing, Reespeak enabled users to vocally transcribe audio files. To produce transcript, Reespeak users repeat content into an off-the-shelf speech recognition engine, which automatically types a broken transcript for them. And I'll come back to how we make use of that broken transcript. Now, the Reespeak system has two main components, the engine and the user application. Now, initially, I was unsure whether the goal of designing a crowdsourcing marketplace that enables users to vocally transcribe audio files is even possible. So I first built a smartphone application and deployed it to low-income students, one of the main target demographics of voice-based services. I then built an accessible version of the same application and deployed it to low-income blind people, another target demographic of these voice-based services. And after carefully investigating these deployments, I converted the smartphone application into an IVR application, which works on basic mobile phones, our actual goal, and deployed it to low-income rural residents, the third target demographic for these voice-based services. All these three applications works in the exact same manner and uses the same underlying engine. Now, to enable users to vocally transcribe audio files, Reespeak uses a 5-step process. In the first step, the engine segments a large audio file for transcription into short utterances that are easier for users to remember. In the second step, each segment is sent to multiple application users. These examples are in English just for the demo. The actual UI and the audio prompts were in local languages. Now, in the third step, the application users listen to a segment, repeat the same words back into the application, remember the content, and repeat the same words back into the application in a quiet environment. The application uses an off-the-shelf speech recognition engine to produce a transcript that is read aloud to the users. The user then verifies if the transcript matches with the original audio segment they heard, and if it does, they submits it in order to receive a new task. So let's see a demo of how users vocally transcribe audio files. Yes?
I'm missing something. So I see that you've got humans verifying that a speech recognition did the correct understanding of the...
So,
I mean, that's the verified part, right?
Oh, yeah. The verified part is, so they listen...
But the verification could be against just doing ASR against the original speech, not their speech, that person's speech.
No. So in this step, they repeat the content,
right,
and they get a transcript. The transcript is read aloud because most of them can't read because of literacy issues. And then they see whether the transcript matches with the original audio segment they heard, like in terms of content.
I think what Mike's asking is, why don't you just run the ASR?
Oh, I see. Oh, because the original audio files have a lot of noises, ambient noises, unclear speeches. So if you submit directly into a speech
recording of the audio,
yes. So it sends
the ASR more successful.
Absolutely. Sorry. Yeah. Thanks for the clarification, Mike. Cool. Yeah, so let's see a demo of how users vocally transcribe audio files. On the left is a blind person using the smartphone application On the right, a group of women are using the IVR application, and all of them are doing the same task.
And listen to the Hindi audio carefully. Mass reward 1 rupee. Play button.
भारतीयों की बातें सुनते हैं उनमें से
Press the record button and repeat what you just heard. This will open a Google app for recognizing speech. Record button.
साथियों की बात सुनते हैं उनमें से
We recognize this. स्वार्थियों की बात सुनते हैं. Does this closely match with the audio file you heard? No button. Yes button.
So the transcript, yes.
I mean, there was verifying the transcript, and there a lot of these are illiterate. So normally you would read that out loud.
Yes. So even in this case, it actually read it aloud, and it wasn't clear. It was the screen reader which read it aloud. In this case, like we built a text-to-speech system, which was like getting the text transcript from the ASR, and that read aloud to the users. And there was a slight delay. That's why they were like zooming in a little bit later than this guy. So the transcript thus produced is expected to have some errors, since users may not fully recognize the content, or the speech recognition engine may make some mistakes in recognizing some words. And to reduce these errors, for each segment, the engine combines multiple users' output transcripts into one best estimation transcript by using string alignment and majority voting process. If the errors in the output from speech recognition engine are randomly distributed, merging the transcript from multiple users improves the overall accuracy if the correct word is recognized for majority of users. The transcript sent by user is then compared with the best estimation transcript generated by the engine to determine user's reward. Now this figure depicts the estimated improvements in accuracy from majority voting and string alignment process. Now x-axis has the speech recognition accuracy for individual users, and y-axis has the accuracy of transcript obtained after string alignment. And assuming that these errors are randomly distributed, the accuracy of aligned transcript increases as the number of speakers increases, but the comparative gain decreases between 3, 5, and 7 users. Now in the final step, the Reespeak engine combines best estimation transcript for each segment into one large file to yield the final transcription. Now while building a new system, a large number of design parameters needs to be investigated in a systematic manner. I thus conducted a series of cognitive experiments, usability studies, and experimental evaluations with 67 low-income participants to identify key design insights into each activities users do to vocally transcribe audio files, like listening, remembering, re-speaking, and verifying transcript. And I apologize that this slide is dense, but just to give you an example, to make it easier for users to remember the segment, I examined how these audio files should be partitioned, what should be their length, and how these files should be presented to the users. And I found that audio files should be partitioned by detecting natural pauses to yield segments of less than 6 seconds in length, and these segments should be presented sequentially to reduce cognitive load and improve content retention. And after incorporating these design insights into Reespeak, the design of Reespeak, I then seeded the engine with nearly 5 hours of Hindi content, such as interviews, songs, news, speeches, telephone calls, and the engine segmented these files to yield over 4,000 microtasks. I then deployed the Reespeak application for 1 month with 25 low-income students, Bespeak application to 24 low-income blind people for another 2 weeks, and the Recall IVR application to 24 rural residents for another 2 weeks. And together, these users completed more than 50,000 microtasks and earned 31,000 Indian rupees by vocally transcribing audio files. The speech recognition accuracy was 71%. The accuracy of transcript obtained after string alignment and majority voting was 92%. The transcription cost was $1.30 per minute, nearly 1/4 of the average market rate, and users earned 50 Indian rupees per hour, nearly 1.5 times the average hourly wage rate in India. Now, the deployment also indicated clear benefits of the approach of asking users to repeat content and using string alignment and majority voting. And this goes back to the question of Mike, like why we shouldn't submit the audio files directly. So in this graph, x-axis has the number of transcripts used in multiple string alignment, and y-axis has the accuracy of speech transcription. Now, the green line plots the accuracy if original files are submitted directly to a speech recognition engine. And in this case, the accuracy was pretty low because of ambient noises and unclear speeches. The yellow line plots the accuracy if users repeat content into a speech recognition engine. And in this case, the accuracy is much higher because users are speaking high quality content in a quiet environment directly into a speech recognition engine. The blue line plots the improvements in accuracy by string alignment and majority voting. And the
I was going to let you finish. I was going to ask, is accuracy here a word error rate or is it?
Word error rate.
Okay.
Yeah. And so accuracy is 1 minus word error rate, or 100 minus word error rate in percentage, yes. And the white line plots the expected improvements in accuracy using the model I showed in a couple of slides back, which assuming that all errors are randomly distributed. The gap between white and blue line is because there were some errors that were systematic in nature. For example, there were certain portions of audio files which were difficult for a majority of users to remember and respeak, or the speech recognition engine had some biases because of which it couldn't recognize the accent of majority of users. Now, comparing the different deployments compared to sighted users, blind users completed 3 times more tasks and earned 2.5 times more money in just half the deployment duration. Blind people were much more enthusiastic to vocally transcribe audio files because most of them earned an earning opportunity for the first time in their life. One of them reported, "I'm grateful to you for creating the app. I earned the money for the first time and learned the value of each rupee." And again, they also self-reported improving their knowledge and pronunciation without us asking anything about it. Another blind person reported, "The app improved my pronunciation as I was speaking words more carefully to get them recognized." They also valued listening to accent from a wide variety of people while they were transcribing the audio files, because that's a skill which they really care about, that they want to be able to understand accents of different people so that they can have more fruitful and faster conversations with others. Now, blind users produce transcripts with 14% less individual accuracy and more cost than sighted users. And the accuracy was low not because of disability, but because they were non-native speakers of Hindi. So during our selection process, they could have conversations with us in Hindi, but they find it really challenging to repeat words in a timed environment into a speech recognition engine because they were non-native speakers. And because the accuracy was low, the engine sent tasks to more people, because of which the engine had to pay more people, which increased the cost of transcription. Now, compared to users who used the smartphone application, rural residents who used the IVR application completed 5 times more tasks and earned 7 times more money in just half the deployment duration. Rural residents were immensely excited at the prospects of earning money by digital work, and they found digital work much easier than manual labor. One of them reported, "Laborers work 9 hours a day to earn 2,500 rupees per month. They can use the application for just 2 hours daily to earn the same amount." Just 2 hours daily for the entire month. Now, compared to the users of smartphone application, IVR application users produce transcripts roughly with the same accuracy, which was a surprise for us because we were thinking that using speech recognition engine on basic phones would reduce the accuracy dramatically, but it didn't. But at more cost, almost double the cost. And the cost was higher because the engine was paying for 2 things, earnings to the user, as well as their cost of calls to use the Recall IVR application itself. Question?
Overall, is the system economically viable?
Great question. So, to revisit, the goal of this work was to enable users to earn money and to provide them free airtime, and Recall generated enough profits to do both. An hour of crowd work on Recall provided users 8 hours of free airtime while supplementing their income at a rate higher than the average hourly wage rate in India. And if all profits are used just to provide them earnings, an hour of crowd work could enable users to get more than 3 times the average hourly wage rate, and an hour of crowd work could give them 12 hours of free airtime if all of it is used to provide them this. So in the final evaluation, I integrated Recall with Sangeet Swara, the system that I showed earlier, and I found that users were successfully doing tasks on Recall to get free airtime to use this service. Moreover, the switching between 2 applications to do tasks and to use airtime did not affect their user experience. So in this work, I made 3 significant contributions. I built the first voice-based crowdsourcing marketplace for illiterate people and basic mobile phone users. I demonstrated that low-income students, blind people, and rural residents can vocally transcribe audio files with high accuracy. And I showed that the profits from crowd work could provide them earnings as well as free airtime to users. thereby giving us a pretty solid approach to address the financial sustainability challenge. The potential of this work to increase the income of blind people is so strong that several social enterprises in the US and India have reached out to me to scale this technology and to commercialize it. Now let's focus on the final challenge, the setup and connectivity challenge. And to remind you, these services are technically challenging to build and maintain for global development organizations and grassroots agencies, because of which it's really hard to replicate them in new contexts. Even when these services work, they operate in silos, impairing information exchange between local community of people who are using this service and global community of people like us who use mainstream social media platforms like Facebook, Twitter, WhatsApp, etc. And to overcome these challenges, I built IVR Junction, a toolkit that makes it easier for anyone to build and maintain voice-based services. All they need is a commodity computer, an off-the-shelf modem costing less than $100, and internet connectivity. Also, the services built using IVR Junction are connected to Facebook and YouTube, thereby giving a global platform to local voices and facilitating information exchange between local community of users and global community of audiences, if desirable. IVR Junction also has a distributed architecture thanks to SkyDrive and Dropbox, which makes it cost-effective as well as resilient to network outages. In the cases, these services are deployed in areas where there is repressive regimes. And because of these advantages, in the last few years, several organizations have used IVR Junction to create the kind of services that I have been describing since the beginning in several countries. And these services have received more than 110,000 phone calls from nearly 25,000 users. And just to give you some examples, the Office of the President of Somaliland used IVR Junction to connect government officials with rural tribal people to improve trust and transparency in the political processes. The government officials record a message by using an IVR service, and citizens respond to these messages, the public policy opinions, etc., by making a simple phone call. And all these conversations are also available on a YouTube channel for the interest of people in diaspora, and are also indexed on the official website of the Parliament of Somaliland. Similarly, Voice of America used IVR Junction to provide reliable and up-to-date news in the local language in Mali. And women rights activists in India used IVR Junction to create a voice petition platform after a gang rape incident that sparked national and international outrage. IVR Junction has received recognition from global development organizations like USAID, human rights agencies like Humanity United and Access Now, as well as mainstream social media platforms like Facebook. And overall, my thesis research has addressed three fundamental challenges of voice-based social computing services to make them more scalable, sustainable, and replicable. And my work has enabled illiterate people, basic mobile phone users, blind people to connect with each other, produce and consume information, and get a voice, agency, and equity. But one of the questions that still bothers me is how can I bring benefits of social computing to people who do not even have mobile phones? And this is not a hypothetical question. During my fieldwork in low-resource environments in India, Africa, even in the US, I found a lot of people who do not have mobile devices. And according to an estimate, there are more than 1.7 billion such women in low and middle-income countries. And unrelated to the fact that they don't have mobile phones, a high majority of them have poor access to health information and health resources, because of which there is an unusual high number of maternal deaths in these regions. And that's just one use case of how there are environments where there are no computing solutions at all, and how there are like huge social challenges in these areas. So my thesis research has outgrown into a new significant direction where I examine ways to bring benefits of social computing to women who do not have mobile phones and who do not have health information. I'll give you a very high-level summary of these investigations, but happy to follow up in more detail after the talk. Now, to enable women without mobile phones to access, report, and share health information, I extended my work beyond voice to include other modalities like video. I worked with Path on Projecting Health, a video-based social computing intervention where local villagers and community health workers come together to create hyper-local infotainment videos discussing key health issues in the local dialect. And once these videos are produced, health workers use a handheld projector to show these videos in facilitated group sessions with pregnant women and new mother to provide them information. And this work is in the domain of health, but it borrows from the work which was done at Microsoft Research India almost 10 years back, and which is now a successful organization, perhaps working in several countries with hundreds of thousands of farmers in the agriculture domain. But the challenges in this intervention and that large-scale product is exactly similar. So I conducted several investigations to improve the design and implementation of Projecting Health. For example, a limitation of this intervention is that there is no way by which women can watch these videos again once they step out of the group session with pregnant women and new mothers. I have examined how different community members like shop owners, students, and community health workers can extend the reach and geographic spread of these videos. Also, these videos are designed locally to improve information absorption. But what is the definition of local? Is it their neighborhood? Is it their village? Is it their city, their county, their state? So I've investigated how different video attributes like content type, accent, quality of actors, production quality should be localized, and how these localizations affect information absorption. And finally, it is extremely difficult to get constructive feedback from women to improve these videos. I have used techniques from behavioral psychology to reduce response bias. And I would like to call out this work because this work has really interesting implications for accessibility researchers as well, because accessibility researchers design technology for people who are absolutely excluded, and they feel so nice that someone is making an effort, and as a result, they give really strong positive feedback, which might not be the honest and critical feedback which you would need as researchers. And Mary and I were talking almost a year back about how this work could be extended in the domain of accessibility. So far, in this intervention, 110 locally produced videos have been shown in 180 Indian villages, impacting lives of an estimated 190,000 rural residents. To reiterate, my research goal is to bring benefits of social computing to billions of people who face literacy, language, socioeconomic, accessibility, and connectivity barriers. In particular, I'm driven to connect them, provide them information, and bring social and digital equity to them. More broadly, much of the work that I have done and that I plan to do follows the framework of build, systematize, and deploy. I build social computing systems for all people, particularly to empower those who are excluded because of their disability or because of other barriers. I systematize how these new users produce, consume, and share information in offline and online social spaces. And I deploy these social computing systems to achieve social good by addressing information and instrumental needs of all people. In today's talk, I showed how I used interdisciplinary methods and how I partnered with several organizations to see my research goals to fruition. Although today I shared only a slice of my research, I have built several social computing systems, including social media platforms, discussion forums, crowdsourcing marketplaces, and information systems. And these systems target different populations, such as low-income blind people, rural residents, indigenous communities, women living in societies with deep-rooted patriarchal values. And these systems attempt to improve their access to education, health, employment, and entertainment. Looking forward, I plan to explore multiple focus directions at the intersection of social computing and accessibility, but in the interest of time, I'll briefly mention only two of them. And this goes back to Steve's question about harassment on these services. So although the services that I built worked exceedingly well for low-income people, blind people, rural residents, I found it disheartening to discover that women face systemic marginalization and encountered flirts, threats, abuses, and blackmail on these services. And it's not just on the services that I have built and deployed in different continents, but also the services which are built by other researchers. And that's the recent Kai paper which you should read to understand like what are these kind of harassing behavior. But just to give you a context, almost 98% of flirty messages, 62% of threatening messages, and 46% of abusive messages were targeted at women, who were only 6% of all users. I also found several instances of disinformation and misinformation on these services. And these challenges are not unique to these services. In fact, mainstream social media organizations also face these grand challenges. So going forward, I plan to use techniques from collaborative filtering, machine learning, public policy to reduce harassment and misinformation on these services as well as other systems which are all around us. But just to give you some really interesting research questions, like what features could identify an appropriate content in local languages audio files? or how to identify interconnected network and interrelated activities of those spreading disinformation, because it's always a disorganized effort. And what to do in situations where collective intelligence of the community is eclipsed by their collective ignorance, as in the case of community condoning bullying of women on the platforms that I have built. Another area of future work that I plan to do is to bring benefits of social computing to people with disabilities. During my PhD, I successfully built several social computing systems for blind people. But vision impairment is just one of the many types of disabilities. As I speak, more than 1 billion people in the world struggle with some form of the disability, and most of them live in low-income settings, even in countries like US. I'm eager to build inclusive technologies to make this world more equitable for people with disabilities. And just to give you one example, I have access to large amount of audio files containing speaker diversity, content diversity, and natural speech elicitation. Using techniques from NLP, I'm really excited to build new local language recognition models and generate labeled speech data. And once I have these models, using methods from HCI and accessibility first design, I want to create local language conversational agents that improve access of health, education, and employment for people with vision impairment and people with motor disabilities. I have already started collaborating with NLP and machine learning researchers in these directions, and I look forward to collaborating with people here. So far, the social computing systems that I have built have reached an estimated 220,000 people in low-resource environments. Looking forward, I'm driven to expand the impact of my research to orders of magnitude more people by solving complex problems at the intersection of computing and society. I would like to thank users who have used the systems that I have built and have allowed me to be part of their lives. I would also like to thank organizations that have funded my research or partnered with me, and thank you all for giving me this fantastic opportunity to present my work. Thank you.
And we have time for more questions.
Yes.
So first of all, I really enjoyed your talk.
Thanks.
At the beginning of the talk, you mentioned that one of the challenges resulted in that many of the services no longer run.
Correct.
But then you demonstrated that at least one of them is financially viable through the crowdsourcing. And I'm wondering, is that one still running? And if not, what were the challenges that resulted in that one turning off?
Yeah, so that's a fantastic question. That's not an example of a service which is running, because it was more or less on the lines of showing that these services could run. And the plans right now is to integrate the crowdsourcing marketplace that I showed into the existing services that are running. And I'll give you, actually, thanks for asking, because I wanted to bring this in the talk and I couldn't, that inspired from the first project I presented, where people are just talking to each other using basic mobile phones, an organization in India called Enable India have created a really large social network of, I don't know how many users they have, perhaps definitely tens of thousands, could be reaching hundreds of thousands of users, who are using the exact same system to connect with each other, to share information with each other about jobs and opportunities. But that service, given that it has reached a larger scale, sustainability is really important. So we are actually working and talking exactly with that organization to include this crowdsourcing marketplace into their system, so that service does not need to be dependent on funding from other organizations. Now, I would also like to say that there are some examples of services which are running. One of them is Sangeet Swara, which is, again, a project from Microsoft Research India. And it requires tremendous effort to run these services. I, as a graduate student, can't run them because I have to write papers, I have to do PhD, pick a new research project. But it requires some champion, who is devoting their entire life to that service or to that organization. It requires people who are constantly generating funds. It requires a team of moderators who are listening to these messages. So this makes it really, not really easy. It works definitely is in the right direction to make it easier for those people to have a sustainable, scalable, and replicable service.
Can I ask you one? This is a great talk, thank you. On the financial side, you showed that you can provide actually relatively low-cost transcriptions, and that model actually can compensate well the people doing that, and it breaks the oops, do I have money for that? But that assumes there is actually a market for these transcriptions.
Absolutely.
Is that indeed the case? Can you find a big customer that
Yes,
will pay for
definitely,
those
definitely. And I can't tell you the name of the organization because this is recorded, but there is a major player who does transcription, and they want to use this technique for transcribing insurance calls. And so even call centers are really, really popular. I mean, of course, in the US, but even in developing regions. And there is a lot of data which requires to be transcribed in these local languages. So that's the other organization I was talking about. So we are thinking how we can transcribe insurance calls in that particular specific case.
Reespeak costs that you mentioned, they
Yes.
is attractive to them.
Definitely. To the extent that they wanted me to leave PhD and join them.
Good sign.
Definitely, definitely. Yes.
So this was a great talk. Thank you very much.
Thanks, Shamsi.
It's very touching for me as well. So I think it was Sangeet Swara where there were participation of women was very low, about
Yes.
6%.
Yes.
And for the next one, I think that was Recall, or what was the name of the next one?
Reespeak Recall, yeah.
Reespeak. Yeah, so did you see more females participating there, or?
So, like in case of Reespeak and Recall, like they were pretty much like a relatively long-term. I mean, I hesitate to say long-term because my definition of long-term is like really long-term, like 2 years, 1 year kind of deployment. But it was definitely running for 1 month and 2 weeks. So, like it was a set. I mean, we asked them like, hey, would you like to participate, right? And we could like control the. I mean, we could gender balance, and we tried doing it in our selection process of participants who were using the app. In case of the first system, it was a system out in the wild, and we had no control on who wants to use it, how they use it. So I spoke about how I want to make these services more inclusive, accessible, safe for women, and there are like bunch of ideas I would like to try. For example, giving women more incentives to join these services, using gender recognition filters to create only women-only services, like creating some form of a constitution on these platforms, appointing sheriffs, like who are like kicking people out, who are like who are recording abusive content on these services. So a bunch of techniques I would like to try to ensure that even these services, Sangeet Swara like services are more gender balanced. But in case of Reespeak, like we were recruiting people and it was pretty much gender balanced.
Before I let Andy get.
Yes.
So one more point is that, so in many cases, especially in these low-income environments, so the mobile phones is a shared resource.
Yes.
So both family members will have access to it, and I wonder if that would affect things in any way. Probably would.
Yes, great question. So in general, like at least to the people we recruited, like they had a mobile device, their personalized smartphone device, because they were generally young, like students or even blind people. Like they were the ones like who used a smartphone because we deployed a smartphone application. But you're right, like we know that there was a shared device in at least 2 homes or 2 participants, and we know that the older family members were doing the tasks as well. So that was pleasantly surprising that, okay, like people who are like old can also do these tasks, especially because they have much lower literacy skills. They haven't interacted much with the smartphone or in that case, it was a basic phone actually. And it goes on to speaking about the values of universal and inclusive design. Yes, indeed.
So I have 2 questions. One that was brought up by your second point, so good. Thank you for doing that. Which is about repeat users. So in your first system, like you kind of showed the slide about traffic, which is great that showed the big
Yes.
thing, but how often do people come back to the system versus like just seeing it, using it because of novelty?
Fantastic question. Honestly, I've forgotten the numbers, but I mean, I can give you some number in some range. So I know that the repeated users were like 30 to 40%, and I would have to look into the paper. There were a lot of people who were just listening the content, not recording it. I know, I've forgotten what I wanted to say. I had some interesting statistics to this answer. So repeated users. Yeah. So for women, right. So I said that there were only 6% of women users. So our analysis indicated that initially they were much more, and they were like excluded from the community by people who were recording abusive and harassment So they were harassing content. So there were like some users which were not repeat users because of what was going on in the content. But in general, I remember that there were like 20% or 30% of the users were repeatedly calling the service. And then there were maybe 10 or 20% of users who were only one-time callers, and the remaining were somewhere in between that they would use it once in 2 days or once in 3 days. My definition of regular users were who were calling at least once a day.
Were the messages anonymous?
No. Yes, it depends on how do you define anonymization, but
Anonymous in that if I listened, if I was one of the users and I listened to the message, how likely would it be that I heard a message from somebody I've actually ever heard of?
very high.
Pretty high.
Yeah.
Okay.
Pretty high. And anonymization, so no one knew like what is the number of a person who recorded the message. So that way it was anonymized, but a lot of people identified with their voice as their identity. So they were really, so for particularly women, like they did not want to record or respond to an abusive messages because they were fearful that if they record a message, then people, most of them did not know them, but they were fearful that someone would recognize that it's them, would tell it to their family members, and there would be like repercussions to them. So people identified a lot with their voice as an identity, even though it was just a voice. We didn't run any filters on voice.
Do you mind if I ask a follow-up?
Yes.
Because being a single trusting person, I can't resist. What if your system had a filter that once I record it, modify the voice so that it becomes not identifiable, but it still has the same performance on the speech recognition system? Would that be valuable?
Yeah, so that's one of the things which we are trying to do, and we really don't know like how it would pan out on the system. There are really interesting theories. Like so the idea which we have debated a lot is like, can we anonymize the voice of person? And then on the positive side, like it gives more agency to people in the sense like they could respond to the kind of messages which, like let's say like hate messages. It could have like really positive connotations to it as well. Like imagine a service which is for people with HIV positive, and it would give them more agency to ask the kind of questions they want to ask. Particularly for women, there is another line of thought, which is that you are disenfranchising them by taking their identity and taking their voice. You are further marginalizing them by taking away their identity. So I mean, there are like two really interesting thoughts in this direction, one which favors anonymization, one which says like, oh, this is the worst thing which you can do. But this is certainly one thing which I would like to try. Yes.
Just two comments or a question as well. So like with the anonymization, I'm sure that it would have a lot to do with the particular domain. Like if it's singing, like in Sangeet Swara, you don't want anonymization of a sung thing, right? Because you're the artist and you're presenting it. So you can easily imagine that would not fly as well. But for something like the HIV or where you're doing healthcare kind of stuff, it's really important.
Definitely.
But I wanted to ask a question that I vaguely remembered, and I'm hoping you can remind me. This is to do with the recalling or the calling again and again to Sangeet Swara. And my memory was that the blind callers represented a disproportionate amount of the content.
Yes.
The active content of actually provided or of the actual ratings.
Absolutely.
This is a really dramatic difference. And I
no, you are spot on. So, I mean, they were everywhere, both in terms of producing content, calling the service, liking, disliking messages, to the extent that we had to put limits on the service. So the reason why average call duration was 5 minutes in that service and not 15 minutes is because we like kept it at 5 minutes. So people just couldn't use it more than 5 minutes in one call. And like when it was not capped, there were people like who would wake up at 4 o'clock in the morning and call the service because the traffic was lower then. Because during the day, like it would be all jammed up because people were just not willing to disconnect the phone call and were having a great time talking to other people and listening to their messages. Yes.
There's a question from someone on Teams who's watching online. They ask, besides the example you showed with the women's health videos that were designed for people who don't have mobile phones, are there any other projects you're part of or projects you're thinking about that are relevant to people who don't have access to mobile phones?
Yeah. So definitely, so I spoke of Digital Green, which is a much larger effort than Projecting Health. It's in the domain of agriculture. We have actually had really long conversations and some deployments with refugee communities in Seattle, and we were creating videos to make their transition easier in the US. So that's one example which comes at comes to my mind. Then we created videos on digital financial services, and in developing regions, digital financial services which are delivered via mobile phones are booming. Some examples are M-Pesa, particularly in India because of some policy changes, some demonetization of particular currency, which boosted a lot of digital financial services, but people are not prepared because of the all accessibility, usability, inclusivity challenges. So creating videos for digital financial services as well to tell people like how they can use a particular application, how they can open the bank account, how they can link the bank account with the mobile phone, etc. So a lot of interesting efforts in those directions as well, which are not as big as the one which I showed in this slide, or digital green, which is much, much bigger.
Any other questions in the room or online? Well, thank you so much for your time.
Thank you so much. Really appreciate it.